Hi, hello, welcome back to Infinity Online Academy. This is Sanju Kumar Nampalli, Physical Science faculty. So now we are going to discuss 20 model questions of a structure of an atom. Okay, so first concentrate each and every question and try to answer the question before the explanation, and after that compare your answer. So then we are going to get effective learning here. So then first see here, first question, we'll start with the first question. So who introduced the elliptical orbit? Who introduced the elliptical orbit? So spherical orbital introduced by the Bohr. Okay na? So Sommerfeld, right? Already in the structure of an atom we discussed that. So Sommerfeld, Bohr's Sommerfeld structure of an atom, in that so what we discussed is Sommerfeld added one elliptical orbital to the Bohr spherical orbit. So that's why your answer is Sommerfeld. Sommerfeld is introduced so these elliptical orbitals. Okay na? Next question. So between violet and red, so which of the light is having the shortest wavelength? Shorter wavelength. So observe here, wavelength, violet and red color. So red, already in the last session you discussed this. So this is a wavelength. Okay na? So wavelength, so one crest to crest, one trough to trough. Okay na? So that is called a wavelength. So next observe here, yeah, this is a wave propagation. So in this wave propagation, this is a shortest wavelength and this is a longest wavelength. Shortest wavelength and a longest wavelength. So which color is having the shortest wavelength? Which color is having the longest wavelength? So right, already in the last session we discussed. So red color light having the longest wavelength and violet color is having the shortest wavelength. So that's why here shortest wavelength is having violet. So red longest, both are not equal, cannot compare. There is a chance to compare this. Okay, so that's why you are going to select which one. So violet color is the shortest wavelength. Next, shape of the p orbital. Right, in the last session we discussed that shape of the orbitals. For example, s orbital having the spherical shape, and p orbitals are having the dumbbell shape. D orbital are having the double dumbbell shape. So f orbitals are having the complex shape. Okay na? So these all we discussed. Now read the question. Shape of the orbital. Shape of the p orbital. Spherical s orbital, dumbbell p orbital, double dumbbell d orbital, and no shape, so no option. Right here, first see spherical s orbital. Here what is asking? P orbital. So p orbital, dumbbell, clear? Okay, right. Next question. See the next question. Okay, yeah, units of frequency, right? Your units of frequency is 1 by, okay na? So 1 by seconds, 1 by second, we are going to take 1 by second as seconds are the units. 1 by second. So that's why you are going to take second inverse. So or second inverse. Second is not, so meter by second is not, meter by distance is no, we are going to compare. So second inverse is the units of the frequency. Seconds inverse, 1 by s or seconds inverse. Okay, so next question, we'll see the next question. For M shell, the value of n, principal quantum number n value. Okay na? So first we'll try to write the principal quantum numbers 1, 2, 3, 4. Okay na? 4 principal quantum numbers. They are also represented with the K shell, L orbit, K shell, L shell, or K, L, M and N. Okay, now tell me, based on your answer question, M. Okay na? So n is belongs to third cell. Okay, so this so next question. Quantum mechanical model was developed by quantum mechanical model. Who developed quantum mechanical model? So Bohr, structure of an atom. So complete structure of an atom. So quantum mechanical model is completely developed by the Max Planck. Okay na? Carl Ludwig Max Planck. Ernst Karl Ludwig Max Planck. So scientist Max Planck is developed by the quantum mechanical model of an atom. Quantum mechanical model of an atom. So we'll see the next question. See the next question. See here. So the electronic configuration of chlorine. Chlorine atomic number 17. Chlorine atomic number 17. So electron configuration 1s2, 2s2, 2p6, 3s2, 3p5, 3p5, 3s2, 3p5. Then valence of chlorine. Valence means combining capacity. So right here, what you will take? Valency is equals to 8 minus valence electrons. Here valency electrons are 7. Valency is 8. So valence 8 minus. So valence is equals to 8 minus 7. Valence 8 electrons, 8 minus valency electrons. Valence electrons are outermost shell electrons are 7. So 8 minus 7, 1. So 1. C is the answer. Remember the formula. Valence is equals to 8 minus valency electrons. Outermost shell electrons. Valence is equals to 8 minus 7. Okay na? Outermost shell electrons means 1s is the inner shell, 2s and 2p are also inner shell. Outer shell is outermost shell is so third shell. This third shell is the outermost orbiter. How many electrons it contains? That electrons are called valence electrons. These valence electrons can be subtracted from the 8. You are going to get a valence combining capacity. Okay, right. We'll see the next question. Which of the following quantum number represents the orientation of orbitals? Okay na? Orientation of orbitals. Okay na? So orientation of the orbitals, principal quantum number, size and shape. Principal quantum number, size and shape. Spin quantum number, it will represent about so electron is revolving in which direction, and magnetic quantum number is right here. Magnetic angular momentum quantum number is also belongs to subshells. So magnetic quantum number. So it will represent orientation of orbitals. Okay na? Clear? So right here, principal quantum number, angular momentum quantum number, spin quantum number, magnetic quantum number. So these are different quantum numbers are says about the different information of the atom. So size and energy. Here angular momentum quantum number of subshells. Spin quantum number, electrons revolves in the anti-clockwise direction or clockwise direction. Magnetic quantum number is orientation of the orbitals. Okay na? Right. Next, vapor. Dash vapor produces yellow light in the street lamps. Okay na? So sodium vapors better. Okay na? Sodium vapors. Sodium gas is filled into the street light lamps. That light is passing through these gases. At that time it will disperse and it will be produce the yellow color light. So yellow color light, what it is? Sodium. Okay na? So this sodium is, it will produce the yellow color light. Okay, clear? So this is about the dash vapors produced by the light in the street lamps. Next question. Inert electron configuration from the following. Inert means last 8th electron group. 8th group elements. 8th group or noble gases. Okay na? So this group also called inert group. inert group. So they have the electronic configuration of ns2 np6 electron configuration. So these electron configuration is called a inert group. Observe here, 2s2 2p6 wrong, 3s2 asal possibility, 3s2 3s3 is wrong, 3s3 is also wrong. So 2s2 2p6, observe here. So D is the correct answer. 1s2 2s2 2p6, this is a inert group electron configuration. Okay, we'll see the next question. Maximum number of electrons in the subshells. Maximum number of electrons are in the subshells. Okay now, right here. So number of electrons are in the subshells. So we know the formula. What is the formula we are going to use? So here electrons are in the orbit. So 2n square. We are going to use 2n square formula. But here, so what is asking? Number of electrons in the subshells. Okay na, subshells. Number of electrons are in the subshells. So 2 into 2l plus 1, 2 into 2l plus 1, this is a formula we are going to use. 2 into 2l plus 1. So once you see first subshell, L is equals to 0. How many electrons? So how many electrons it contains? So 2 into 2l, L value 0 plus 1. So is equals to 2 into 2 zeros are 0 plus 1. So next 0 plus 1, 1. 2 ones are 2. L is equals to 0. S orbital. How many electrons it contains? Subshell, 2 electrons. Okay na? So this is a formula. Right here, 2 into 2l plus 1. We are going to use the number of electrons of a subshells. Okay, next question. We'll see the next question. Maximum number of electrons are in the D subshell. Maximum number of electrons are in the D subshell. Right? What are the formula we are going to use? So here, observe carefully. 2 into 2l plus 1 for D value. For D value. So what is the formula we are going to use? So L is equals to 0. L is equals to 0, S orbital. L is equals to 0, S orbital. L is equals to 1, P orbital. L is equals to 2, D orbital. L is equals to 3, F orbital. Okay now, right here. So L value, then we are going to take 2. 2 into 2 plus 1. Okay now, 2 twos are 4 plus 1. And 4 plus 1, 5. 2 into 5. 2 5s are 10. Okay, 2 5s are 10. How many electrons are? D subshell, 10 electrons. It can give space for the 10 electrons. So next question. Let's see the next question, 13th question. Orbitals of the same energy are called same energy, degenerated orbitals. They are called degenerated orbitals. Degenerated orbitals. Same energy levels in the orbit. They are called degenerated orbitals. Generate orbitals not. Stationary means fixed energy. Energetic is not. So degenerated orbitals are called same energy level, equal energy level shells. Equal energy levels. Next, which quantum number gives the information about the size and energy? Size and energy, principal quantum number. Size and energy. Size and energy, principal quantum number. Okay na? So principal quantum number is the answer. So next question, 15th question. The speed of the light. Right? Already you know this. Speed of a light in the vacuum, 3 into 10 to the power of 8 meter per second. This is the speed of a light in vacuum. Speed of a light in vacuum. Here 3 into 10 to the power of 8 kilometers. Kilometers wrong. So 3 into 10 to the power of 8 meter per second. Meter per second. Correct answer. 10 to the power of power minus 10. These are the wrong answers. 3 into 10 to the power of 8. 3 into 10 to the power of 8 meter per second. The correct answer. So we'll see the next question. Right here, see here the relation between the frequency and wavelength. frequency and wavelength are inversely proportional. Inversely proportional, right here. Frequency n, okay, frequency n is inversely proportional to wavelength. So this is a formula. This is a direct formula. He asked a direct formula. What is the relationship between the wavelength and the frequency? Okay, so this is the answer. Next, cupric chloride produces which color flame? Which color? So when you are taken cupric chloride, a pinch of cupric chloride, and it is attached to the platinum loop, and after that with the help of the non-luminous flame you are burning, it will produces green color flame. Okay na? Yellow, red, orange, these are wrong. So green color light it will be. So one more also, strontium chloride crimson red color. Strontium chloride is crimson red color light it will be produces. Maximum number of electrons are present in a shell. Maximum number of electrons. Formula. What is the formula? 2n square. 2n square. Maximum number of 2n square. Observe here. So first shell 2, 1 square, 2, 1 ones are 1. So 2 into 1s are 2. First shell maximum 2. Next, if second shell 2, 2 twos are 4, 2 fours are 8. Next, third shell 3 threes are 9, 2 into 9s are 18. Next, 4 fours are 16, 2 into 16s are 32. Okay, so these are the maximum number of electrons in the orbit, okay, in the shell. So this is the formula, 2n square formula we are going to use. Next question, the maximum number of electrons are that can be accommodated in M shell. Maximum number of electrons are in the M shell. K, L, M, N. So first n value 1, 2, 3, 4. So 2n square I will use the formula. 2n square here I will use. So n value 3. Okay now, principal quantum number 3 value. 3 squares are 9. So 9, 2 into 9 are 18. How many electrons maximum? 18 electrons maximum in the M shell. Okay, so next question. See the next question. The electron with a quantum numbers n is equals to 3. N is equals to 3 means third main shell. So in the electron configuration, first what you will write in the NLX formula, NLX formula. So here n value 3. So then L value 0. L value 0 means which subshell? S subshell. Yes. L value 0. Yes. So right here it belongs to this plus of that electron having the plus of. So here 1 if you will take, then these electron belongs to which orbital, which orbit. So 3p, 3d, 3f, 3s. This is the answer by using the NLX electron configuration. Okay na? So these are the 20 model questions of the structure of an atom. Okay, so practice well and listen the classes properly, and after that so practice model questions, more number of model questions. If you will practice, compulsory you are going to get a good knowledge, and by using that knowledge you are going to write exam effectively. Okay, so this is 20 model questions of the structure of an atom. Right, in the next session we will meet with the another important topic. Thank you very much.